Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thank you for the opportunity. My name is Avian Budi. Let me present a paper of the day. It's titled Energy Management System by Hybrid Battery and Supercapacitor. Okay, let me share screen it first. Okay, so here's the presentation. Energy management control based on standalone photovoltaic battery and supercapacitor hybrid energy storage system using PR controller. So the author is Mr. Sudibyo, Avian Budi, me as the presenter, and then Mr. Samsulanam, Professor Muhammad Asyari, and Professor Adi Subianto. We are from Institute Technology, Surabaya. So the presentation outline, we have introduction, and then novelty and proposed method, and then system and input model, and then simulation results and conclusion. Okay, next. So we know that renewable energy is energy generated from sources that are not depleted and can be replenished by human life. The most common example including wind, solar, and geothermal, biomass, and hydropower. This is different from non-renewable energy sources such as fossil fuels. And then now we are focused in standalone photovoltaic as in this object for the research. Standalone photovoltaic system must be equipped with energy storage system. The types of energy storage today is varies. We know batteries, we know supercapacitor, and anything else, including using multiple energy storage with parallel connection or series connection. However, energy management system for multiple energy storage system in parallel should have function properly for better stability and continuity. So our concern here is power system stability and continuity for standalone photovoltaic with hybrid battery and supercapacitor system. Okay. So the novelty and purpose method here, this paper will present some improvement based on control system in the energy management system. The aspect that act as parameter in the voltage and power stability, the results without control and with PR control will be compared. More noise and oscillation, high starting overshoot and undershoot will be categorized as less contribution to system stability. So this is the system and input model for modified part. We know the MPPT here is the very useful equipment for the research because power input is obtained through the conversion of solar and wind using photovoltaic. Then the voltage and current will be read as sensor each PV. MPPT will operate according to algorithm with P&O algorithm, and then when the power produced by PV is greater than load power, then the surplus will be used to converter and does not produce power, so it will be consumed directly. And then this is the parameter of the batteries and the parameter of supercapacitor. So we use lithium ion batteries because it's less, we have much load but less loss, so we use lithium ion. The nominal voltage is 24, the rated capacity is 14, and the initial state of charge is 50 because we have to know the high and low for the batteries because it is the main energy storage here. The battery response time is 0.1. And then for the parameter for supercapacitor, the rated capacitance is 29, and the equivalent DC series capacitance is 0.003, and the rated voltage is 32. The number of series is 1 and parallel is 1, so the initial voltage is same with the rated voltage is 32, and then the operating temperature we use 25. So for the input, the data used in simulator divided into two phases. The 0 to 1 second or first phase we know contains the normal condition using Surabaya Indonesia sample at maximum irradiance during sunny day is 1K, and then for 1 to 2 seconds or second phase, last phase, contains the condition where the cloud N or the pollutant in terms of dust pollutant cover up the panel, so the irradiance is half of the maximum, up to half, and then we use 500, and then the temperature is given constant and 25 because we have no concern in temperature variables. And then the simulation is only 2 seconds due to simulation computational load limit. We use MATLAB Simulink, uh, and the load limit we have 2 seconds in our computer. And has the given model, so load power can be examined because the load power has to be compared for the stability. This is the simulation result for uncontrolled. We know from the simulation results the control system cannot maintain the stability in different irradiance input due to direct input power from PV to the load at the same bus. So the bus is the same direct couple. So at 1000 we have not the same as 500 irradiance. This is the simulation results for battery during uncontrolled, and then this is the supercapacitor during uncontrolled. The supercapacitor shows there is no much contribution because the slope in the irradiance change are almost the same. Besides, the supercapacitor has given non-first order input, so it is very small compared to the first order in real power comparison. From the simulation results, the supercapacitor acts as a change compensator, while the battery acts as the main energy storage supply. While at full irradiance, the battery is charging 232.344 watts, and the supercapacitor use 3.806 watts. While at half irradiance, because of input is less than load power demand, the load power demand is 500 since the load input is 484.239 watts. The battery is discharged at 14.048 watts, and supercapacitor is 3.335 watts to the system. The total load power demand of 500 watts is satisfied with the input of 484 plus 14 plus 3 in the so it is equal to 501 watts. In the 1000 irradiance simulation, load power is 180 watt more than the demand power. So this is a loss for the PV, and then it be consumed by the converter directly and the battery and supercapacitor, resulting in loss in heat. This is the simulation results for PI control. From the simulation results, the PI control can maintain the stability for irradiance input, increasing the power efficiency by decreasing 36.119% power into the load. In PI control battery system, the battery shows there is more contribution during the half irradiance than the end control system. In the PI control system, the supercapacitor shows there is not much more contribution because the slope is irradiance change almost the same. This is the same for the PI control in the supercapacitor, but the main is very high, so efficiency is goes up high too. From the simulation results, it is clear that PI control system has the better results due to compensation of load power surplus during full irradiance and increase the battery input by 162.261 watts or 1969.86% more power to the batteries. The supercapacitor has not affected significantly due to its contribution as secondary energy storage here. So the conclusion from the results, it is obtained that PI control standalone system has the better results due to compensation of load power surplus during full irradiance and increase the battery input by 162.261 watts, and the load has been optimized input full irradiance by the decreasing of 178.309 watts and for half irradiance by increasing of 15.166 watts. Okay, thank you for the presentation.